This is my lab 5 report. The option I choose is the impossible trampoline. So we're gonna analyze the video about. So the end of the lab is to figure it out. Has he discovered a way to violate conservation of energy? To do that, we have to analyze trampoline motion. The fundamental physics principle we use is the energy principle, which states delta K plus delta U delta E equals the work the surroundings do plus heat. For the sake of convenience, we just found a video from YouTube. Um, there's more showing the motion of trampoline without any camera flipping stuff like that. Okay, this is what I'm analyzing the video in Tracker. We also made a computational model. So in this case, we set the gravitational acceleration, the mass, the spring constant, also the damping factor. So basically we treat the trampoline as a kind of special spring, and also the damping factor means something that some factors or some numbers you have to set to stop the motion of the trampoline. So if it's 0, you won't stop from jumping, which is we don't want. And there we set the little kids as a ball, and we set a line to be the trampoline. And we got our vectors of velocity, also the delta t. So in the while loop, we got our forces calculated, both of the gravity or the trampoline. And also we update the motion, which will calculate the acceleration, the velocity update, and the position update, and we plot the y versus time graph. And this is how it looks. So to compare these two graphs, we found that in reality, which is the small kid's case, she actually jumping higher. But in our computational model, it's jumping lower and lower, which is kind of violates the energy principle. So we're gonna analyze the energy behind it to figure it out the reason why the little girl actually jumped higher. So in our computational model, we can simulate the energy changing as gravitational potential energy becomes the kinetic energy, which is you kind of accelerates, kind of fall to the trampoline, and also your kinetic energy transfers to the spring energy, and your spring energy you bounce back, and the spring energy converted to the kinetic energy, and finally got the UG, which is the height. So in this case, we include a damping factor, which would make some of the energy into heat. So this is the computational model case. But in reality, we found that the little girl actually bends a little bit of her knees. So this small motion actually makes a big difference, which means that she actually includes her body chemical energy into the whole energy calculations. So in this case, we set the gravitational potential energy initial plus the chemical energy converted to the kinetic energy, and then converted to the spring energy, and then converted to kinetic energy, and finally the gravitational potential energy, which is different. Therefore, she jumps higher. So reflection, the trampoline motion still follows the conservation of energy. It is misunderstood since we don't take account all of the energy components and also its calculations. But in this lab, we don't take account things like air resistance, sound energy, etc. but we just get a conclusion that it still follows conservation of energy.